Hello, this is Dylan Crockett for uh, sorry, the coding assignment for the statistical AI track assignment where we are improving our genetic algorithms uh, with 5 or 20 things for the base project. The base project I had was already a little bit edited because I uh, already had changed a few things, but this is just adding upon that. The only repeat thing I think I have here is the graph, which I added myself in the previous one, but this will uh, be a continuation of other things as well, like the UI that I added, as well as an improved genetic algorithm. I was planning on adding data, live agent information, but I'm a little bit sick right now, and I will re-upload the project later with this added, and I just couldn't finish it tonight. So without further ado, I'm going to show off some of the new features. So the first thing I added, of course, is a better UI. So you can now change the generations and the population, the amount of generations in the simulation, and the population of each generation through the UI. So you can also start the simulation. So let's do that. So it's going to run it. We didn't have a very good run because these are like the default settings, which usually don't produce good results. So of course we can now change that to be something that we want, like 50 and 50. This will perform hopefully better. And it did a little bit better. So you can see they lived a little bit longer. They had a better score over the generations. Um, so yes, another thing is the improved graph. We'll be able to see here in a second. It shows both the blue line, which is the best performing agent per generation, and the orange line, which is the average score over each generation. So the combination of the scores of all agents per generation. Um, Apart from this, the improved genetic algorithm, the main thing I improved was the mutation rate lowers as the agents perform better. So agents that start to reach the max score, which in this case is 300, start to have their, as the top agents reach the max score of 300, their rate of mutation lowers dramatically. Um, I don't remember where I had it, but I believe I had it graphed out. There's two options that I chose, and I can kind of remove this 100 to show the curve of the actual mutation rate. So as you can kind of see, here, let me just zoom out even more. There's two that I was choosing to mess with. So as you can see, as they, well, this is the formula that I'm using to do this, but as the agents perform better, their mutation rate lowers from where if they're getting 0, it's at 100% mutation rate, all the way down to 0 if they're performing the best. These are two ones that I was messing with. I've been testing a little bit. I do like the more logarithmic um, mutation curve because it encourages agents to be really good versus just kind of being average all the way through. They're both, one of them's exponential, reverse exponential, and the other one's logarithmic. But besides that, I added those. Uh, where was it? I believe it's in the mutation function, which is right here. So there's two of them. Currently, I'm running with the logarithmic version, but you can, if you would like, you can switch between the two. I've found that I prefer the logarithmic version versus the exponential. But here, if we go back to the UI, we can see that. Yeah, let's see if we get a better generation. We're kind of getting unlucky, but uh, let's just increase the generations to 100, so hopefully we'll get a better performing generation. But the goal of doing this was that the variance between the top score and the average score is a little bit less. So here you can see a really good agent was developed. You can watch him run. It also shows the best agent per generation at the end. Here you can kind of see as the agent gets better, the average gets better. It kind of stays somewhat flat. Uh, I've had runs where once one of the agents hits the top score, the average also hits the top score. Um, it's just kind of being so you can kind of see that here. It's closer to matching. The jumps are more close. So there's not as much variance between the best performing and the average in total. So that way, the population also gets better as the top agent. There's a little bit like before you'd have an agent performing as the best possible and still having agents that are performing um, like the poorest possible, dying within 10 ticks of the simulation running. So that was unideal. So here we can kind of see we got a really good what the algorithm was designed to do, what the improved algorithm was designed to do. Um, it's going to take here a second because it's doing really well, so the runtime is going to be a bit longer. But as we can see here on the graph when it shows up, see we got a really good agent. Just kind of sits there and does the performance really well. But once the graph shows up, this is the real goal of the genetic reducing the mutation as it got better, because you can get this little spike, and once the agent starts performing well, the average gets really consistent. And you can have cases where all agents in the generation perform the best possible. All of them get the perfect score. Um, I also added it where in the actual evolution function, which we can see down here, um, it keeps track of the best agent possible, and then we'll display them here at the end again, and it will we scroll up a little bit. um, sorry, it's taking a bit long. It will tell you the best performing generation was found at generation 99, and the best agent of that generation was agent 11. Because if you get a perfect generation, for example, one that all scores perfectly, as we can kind of see here, generation 99 did, the best agent will be the last agent, and well, not necessarily, but the best agent's not necessarily they're all the best agent because they all performed the same. And generation 99 was a perfect generation, so even though generation 98 was also a perfect generation, generation 99 overrid it because it was also as perfect. So you'll get the most recent perfect generation from that algorithm running. So like I said, I was still planning on adding the live view. It would the goal would be that it displays the I kind of listed it here, the neural network values of each agent as they run. So currently I have it disabled, so when you run the simulation, it does all the calculations by itself uh, in the background, so you don't see the agents training themselves. But the goal would be that you could see the agents training and dying over and over again, each generation by generation. It'd take a long time, but then you go over here, you'd have a second window that would show uh, what decision each agent's training, and if I got enough time to work on this, which maybe this will be an implementation for a future project. You could step by step through each generation and per population of agents to see what decisions they're making, why they're making those decisions, and get a real down to the metal look at the neural networks. So that's pretty much all that. Like I said, I'll probably be resubmitting this hopefully tomorrow. Um, with a where when it does the training, it will show the other rather than just showing this information down here. It will also show the agent actually training as well as the uh, output information of the agent. Thank you for your time, and I hope you enjoy maybe messing around with this fun tool that I made. Thank you.